Hi everyone, it's Mr. Baker here. Today I'm going to show you an online activity of how you can find the specific latent heat of fusion for water. So here I'm using Focus e-learning and their simulation to find out the specific latent heat of fusion for water, or in this case the specific latent heat of ice. And this is kind of experiment that you would do to find this out, and this is the equipment that you may use. One of the ways you could do it is by doing it like this. So you would have a balance with a beaker, and then above that, with a clamp and a stand, you would have a funnel and lots of crushed ice in there, and then you would have a heater which is linked to a power source and either an energy meter, or you'd have an ammeter and a voltmeter. This is just literally the power source here, showing you the voltage, so 12 volts, and then a timer as well. So the first thing you would do if you had all of this equipment here is you would find out, or over a certain amount of time, what would happen if I didn't switch the heater on at all, and if I just literally let the ice melt. What we're going to do, the whole point of this experiment is to watch ice melt. Yes, that's the experiment. We're watching ice melt, and as we're watching ice melt, we're going to basically measure how much of that has melted. If we know how much energy we've put in to the heater, we're basically saying all of the energy we put into the heater goes into the ice, and then if we know how much energy we've put in, we know how much in kilograms or in grams has melted, then we know the energy and we know the mass. And if you can remember back to the equation, basically the energy equals the mass times the specific latent heat, in this case the specific latent heat of fusion. So the first thing we do is we would not turn the heater on. So I'm going to click this button here. You can see it says control experiment heater off, and you can see the ammeter goes off, the voltmeter goes to 0, and then I would just measure it for a certain amount of time. So there you go, it's measured it for 5 minutes. 5 minutes, so 5 times 60, so 300 seconds, because we'd have to measure it in seconds. So 300 seconds, and it would be 3 grams would have melted in that time. Okay, so that's the first thing we would have to note down. So if you're following along with this, so you can actually do this, you'd need to just jot that down then, that 3 grams has melted after 5 minutes, and then you'd have to convert that 5 times 60 into 300 seconds. So you can literally just jot that down. Then what we're going to do is we're going to turn it back on again, and again measure it for 5 minutes. So now we have got the voltage is 12, so you'd have to write these things down. The voltage is 12, the current is 4.17 amps, so that's the potential difference. The voltage is 12 volts there. The current, the electric current, is 4.17 amps, and the amount that has now melted is 47.988 grams. So that's how much is melted, 47.988 grams, and that again was in the same amount of time. So basically, when you switch the heater on and you leave it for 5 minutes, that is how much ice melts into water. Okay? So from the experiment we have just done, we have found that in 300 seconds, 3 grams of ice has melted when the heater was turned off. With the heater set to 12 volts and 4.17 amps, 47.988 grams of ice then melted. So we know that the heater made 44.988 grams melt, because if we didn't have the heater on, only 3 grams would have melted. So we take that away from our 47.988, and so we get 44.988 grams melted because of the heater being on. So we have got to find out how much energy was transferred to the heater, and we can do that by using an equation for electrical energy. Electrical energy equals the electric current times the voltage, or the potential difference, times the time in seconds that it's been on for. So the electrical energy transferred was 4.17 because that's our current, or 4.17, and it was times 12 because it was 12 volts, and it was times 300 seconds because we had 5 minutes, and 300 seconds equals 5 minutes. So 4.17 times 12 times 300 equals 15,012 joules. Now the mass of the melted ice is 44.988 grams, so we can convert that into kilograms, so it would be 0.044988 kilograms. So now we've got all the information we need to find the specific latent heat. So we use the equation, the energy equals the mass times the specific latent heat. The equation for specific latent heat that we can use. So our energy is 15,012, and that equals 0.044988, which was the mass in kilograms, times the specific latent heat. If we rearrange that, we get that the specific latent heat equals 15,012 divided by 0.044988, which equals 333,689 joules per kilogram. So from our little experiment that we've done online, that's what we have found as a specific latent heat of fusion of ice. So it might be worth having a little look, seeing if we can do some research. What is the specific latent heat of fusion of ice? Was this right? And then if it wasn't, maybe think about why you think the result might not have been exactly correct, and if it is correct, explain why it is. So really what you've got to be able to do is to use this equation, and we sort of used it in context here, looking at the specific latent heat of fusion of ice. If you were to find out the specific latent vaporization of water, then you'd be doing an experiment very similar, but just boiling water and seeing how much water had been boiled, looking at how much electrical energy you'd put in, doing exactly the same thing, measuring the mass of the water that's changed into vapor, and doing a very similar calculation at the end of it. And you may get questions like this asking you to describe how to do it. You probably shouldn't really get questions asking you to describe the method, I wouldn't have thought, at Key Stage 4, because it's not one of the required practicals. Okay, that's it for this one. I've been Mr. Baker. Thank you very much.